Hi, I'm Chitra and I'm going to introduce the topic trigonometry to you today. Trigonometry is derived from the Greek word trigon meaning three sides and metron meaning measurement. So this tells us that trigonometry is the study of relationship between sides and angles of a triangle. Now the common feeling is mathematics is an abstract subject and doesn't find use in day-to-day applications. In order to dispel the misconception, I'm going to show you where trigonometry is used first, right? I'll take you on a virtual study tour to Qutub Minar. Let us imagine we are all standing around Qutub Minar and we are looking at the structure, enjoying the beauty of it. Now, I can imagine a virtual right angle triangle to be embedded between our eye and the tower and the minar. Okay, now how nice it would be if we could measure the height of the minar without actually having to do it. Okay, is it possible to calculate the height of the minar? Yes, using trigonometry, it is indeed possible to measure the height of the minar. Okay, next we proceed to another example. I'll take you out to the field where a little boy is admiring the hot air balloon. See, he's looking at the hot air balloon. In a while, the balloon moves away and he's standing at the same place, is observing the balloon at a higher distance and farther away. Now, the question is it possible for the boy to measure the height of the balloon from the ground in the second instance? And is it possible to measure the distance between the two positions of the balloon in the horizontal plane? The answer to both is yes. Using trigonometry, we can very well do it. Now today, let me introduce the concept of trigonometry to you. What exactly trigonometry is and the ratios of sides and angles of the triangle that we are going to study. Before that, let me recapitulate the concept of right angle triangle which you have learned. You've learned right angle triangle, isn't it? Yes. We have learned that in a right angle triangle, one angle is fixed at 90 degrees. Yes, I'm drawing a right angle triangle now. Okay, this will be my right angle triangle. I'll mark the right angle here. The small square which is drawn here indicates this angle is 90 degrees. We have also learned that the side opposite to the 90-degree angle is called as the hypotenuse, denoted by the letter H. See, when you look at this, the remaining two angles should be acute angles because they add up to 90 degrees. So let me call one of the acute angles as theta. The side opposite to theta is called as the opposite side, denoted by the letter O. And the side holding the angle theta is called as the adjacent side and is denoted by the letter A. Now let us study trigonometric ratios which are defined as follows. Okay, sine theta is defined as the ratio of opposite side to hypotenuse. See, sine, this is not sine into theta, it is sine theta, a function. It's defined as the ratio of opposite side to hypotenuse. Next, we define cosine theta or cos theta as the ratio of adjacent side to hypotenuse and the tangent of theta or tan theta as the ratio of opposite side to adjacent side. Having defined these three, we define their reciprocals as follows. See, cosine of theta is the reciprocal of sine theta and is defined as the ratio of hypotenuse to opposite side. Secant theta or sec theta would be the ratio of hypotenuse to adjacent side because it's the reciprocal of cos theta, and cotangent theta or cot theta is the reciprocal of adjacent side to opposite side. It's the reciprocal of tan theta, so it is adjacent side to opposite side. Now, these are the trigonometric ratios which we have learned. The value of sine, cosine, tangent for a given theta will not change. depending upon the size of the triangle, it will not change. It is independent of the sides of the triangle. It's only dependent on the angle. Now you can ask how such a thing is possible. Let me show you. See, let's draw two right angle triangles having different measures but the same angle theta. See, I'll draw one here and one here. I have two triangles ABC. I could call this as AOB and this is COD. When I consider these two triangles, the angle theta is common to both the triangles AOB and COD. So these, and this angle is 90 degrees. This is also 90 degrees. So third angle is also equal. So these two triangles are similar. Since the triangles are similar, we have the ratio of corresponding sides as equal. That is AB by CD should be equal to OB by OD, and that is equal to OA by OC. Now sin theta would be from triangle AOB, from this triangle, first triangle would be sin theta would be opposite side AB by OA, and from the second triangle it would be equal to CD by OC. See, these two are one, so I could cross multiply this and get sin theta AB by OA is equal to CD by OC. So value of sin theta is the same because these two ratios are the same, as you can see from here. See, when I compare these two, AB by CD should be equal to OA by OC. Therefore, sin theta value is the same when you compare these two. AB by CD should be equal to OA by OC. Therefore, sin theta does not change. It does not depend upon the length of the sides of the triangle. It only depends upon the angle theta. Right? So also for cosine and tangent of theta. I hope you have understood all the fundamental concepts in trigonometry, which is the definition of sine, cosine, and tangent of functions. Thank you.